Okay, here we go again. We're going to use the fundamental theorem of part 1 to find the derivative of this strange integral. Lower limit is pi over 2. Upper limit is not x. No, it's not. It's a function of x. It's x squared. Cosine of t will be our little f of t dt. So take a break, go back and look at the theorem, fundamental theorem part 1, and then come back here and let's get at this problem. Okay, so we have quote g of x, not really g of x, is equal to the integral from pi over 2 to x squared cosine of t dt. So here's our f of t, it's cosine t. But we're going to have to let u equal the upper limit, x squared. Then when we take the derivative of u, we're going to get 2 times x. We'll be using that in the chain rule. So to answer the question, the derivative with respect to x of the given interval from pi over 2 to x squared cosine of t dt is equal to the derivative of, well, you know what? It's not really g of x, it's g of x squared, because the fact of the matter is that according to the fundamental theorem, g of x would be the integral from the lower limit to x to the first. See, I almost put the second. No, just x to the first. So this is actually g of the upper limit, x squared. In other words, we're looking for the derivative of g of u. Well, according to the fundamental theorem part 1, f of u is a derivative of g of u, and then we have to hit it, multiply it by u prime because of the chain rule, and that's because g of u is g of a function of x, it's a composite function. Okay, what's f of u? Well, f of t was given to be cosine of t, therefore f of u has to be cosine of u. All right, so we replace f of u with cosine u, and what's u prime? Well, u was equal to x squared, therefore u prime was 2x. So we replace u prime with 2x. That means that the answer is the cosine of x squared and then multiply the cosine function, the entire function, by 2x. And the reason you do that is because if u is equal to x squared, then the cosine of u is a cosine of x squared.